Thank you. I'm honored to participate in this webinar. And the topic of my presentation is where minimal is critical, infrared optics for drones, Ophir's contributions in the field of military drones. I will start my presentation with a short introduction of Ophir Optronics. Then I will give some background about the UAVs, which stand for Unmanned Aerial Vehicles, and drones industry. Then I will focus on the optics, specifically infrared optics for drones and UAVs. Next, I will describe the Ophir family of lenses specially designed for the UAV and drones market, and I will conclude with a brief summary. So first about Ophir. Ophir designs and manufactures optics and optical assemblies, especially but not only infrared optics for all markets, defense, commercial, and industrial. In the commercial market, Ophir's products are used for thermal imaging and are integrated in a variety of commercial applications, offering innovative, cost-effective solutions for high-volume, lightweight infrared optics. In the defense market, Ophir is a leading provider of high-quality infrared optical components and assemblies for sophisticated military applications, with decades of experience in meeting defense standards in terms of quality. As for the industrial market, Ophir serves the industrial high-power laser material processing manufacturers and users, delivering the highest quality components and assemblies for both fiber and CO2 lasers, cutting and welding machines. Ophir is recognized as a technology leader in delivering innovative, high-quality and reliable solutions with over 40 years of experience, cutting-edge design and manufacturing capabilities, as well as military credibility. Ophir's comprehensive portfolio includes a large variety of optical components and lens assemblies. Ophir is known as one of the highest quality optics companies in the world and is ISO 9001:2015 certified, and also has the AS 9100 aviation quality standard. Some background on the drone and UAV industry. According to recent market research, the worldwide UAV market will total in $90 billion in the next 10 years. The main applications include military surveillance, target acquisition, security, search and rescue operations, safety, homeland security, border control, and police. In this slide, you can see the various main parts comprising a typical UAV gimbal: a day camera, laser rangefinder, LRF, laser pointer, and the thermal imaging channel, which includes the infrared lens. As for the trends in optics for drones, I would like to note that the large UAVs and drones used for defense present some specific demands from the optics, namely increased camera detector resolution and format, decreased pixel size, and increased operational ranges, while smaller drones for commercial use present greater SWaP restraints. SWaP stands for size, weight, and power consumption. Next, I would like to elaborate on the lens contribution to the drone and UAV mission success. Firstly, we must understand that advanced detector resolution will not improve imaging performance without an improvement in the lens quality. In an optics limited system, an inferior lens will produce an inferior image even with the best detector. Secondly, to match high-performance detectors, lower f-number, tighter tolerances are required in order to obtain lenses with minimal aberrations. Also, lenses must have a long focal length and high image quality for maximum target detection ranges. One of the best practical solutions for thermal imaging optics for UAVs are continuous zoom lenses, which reduce lens size and weight while keeping high performance and better mission flexibility by allowing changes in magnification during a UAV operation. I would like to emphasize that a single zoom lens is smaller and lighter than using multiple single field of view lenses. In summary of this section, lenses for drones and UAVs must have compact size, lightweight design, and long focal lengths, while also retaining high image quality and accuracy. Now I would like to elaborate on Ophir's infrared lenses for drones and UAVs. First, how do we meet SWAP goals? Well, we do it by combining several methods, including innovative optical and mechanical designs, folded lens design and assembly, utilizing a variety of existing continuous zoom lenses, and finally, cutting-edge production technologies. To demonstrate this point, here are some characteristics of our products. Small form factor lenses to fit miniature gimbals, UAV payloads, drones, and handheld device applications. Ultra-lightweight zoom and fixed focus lenses. Folded optics technology when required. Diffraction-limited optical design. Athermal compensation. Continuous zoom with fixed f-number maintained through the full zoom range. Focus maintained through the zoom. Tight through zoom bore sight. Fast field of view change. Preset discrete optical zoom positions. Compatibility with major medium wave and long wave detectors. CPU controlled via RS485 or RS232. Low power consumption and excellent optical coatings, including high durability and low reflection hard carbon in AR coatings. Before concluding, I will take a few products as case studies for Ophir's infrared optics for UAVs and drones. First case study would be our light IR 20 to 275 mm zoom lens. This lens is the smallest, lightest, and most compact lens of its type on the market, with operating temperature range from -35 to up to +65 C. Compared to our older 19 to 75 mm lens, the new lens weight has reduced from 445 grams down to 264 grams, which is more than 40% reduction. Lens dimensions have been also significantly reduced to satisfy SWAP requirements. Next product is our long wave 15 to 75 mm zoom lens for uncooled detectors. As discussed earlier, one aspect of the continuous progress in infrared detector technology is reduced pixel size. The new generation of uncooled infrared detectors has a pixel pitch of 10 to 12 micron, which is much smaller than the 17 micron pixel pitch of the previous generation. Utilizing this reduction in pixel pitch, we designed the 1575 zoom lens for the new generation of detectors in such a way that it will yield the same performance in terms of operational ranges as our older 26 to 105 millimeter zoom lens, which was designed for the previous generation 17 micron pixel detectors. Consequently, we succeeded to reduce the lens weight from 575 grams down to 320 grams, which is 44% reduction. Similarly, the physical lens length was shortened from 122.5 millimeter to 88 millimeter. Now, I would like to describe our 16 180 millimeter zoom lens for medium wave infrared. In these slides, you can see that this lens has a folded optics design. I would like to mention that the solid model shown here includes the detector module with its cooler, and to emphasize that this feature of compact system design was made possible only due to the folded optics design. The motivation and core requirements in the optics design were to shorten system overall length while maintaining a long focal length, long optical lengths for reduced sensitivity to tolerances, efficient volume utilization, and compact design, which is ideal for airborne gimbals. Main challenges we faced designing the optical system include complicated optical design, complex integration, complex line of sight calibration process, extra optical elements with limited volume and weight, and image tilt. Key features of this lens are medium wave infrared spectral range, focal plane array format of 640 by 512 10 micron pixel pitch, 11x zoom ratio, high image quality, and small footprint, which is swap compatible. The following slides describe the nominal MTF performance of this lens in various zoom positions. As can be seen, the high performance is kept over the full zoom range from wide to narrow. The last product I would like to mention is our 28 to 850 millimeter zoom lens. The main feature of this lens are medium wave infrared spectral range, high definition detector format of 1280 by 1024, 15 micron pixel pitch, 30x zoom ratio, folded design, tight boresat retention, and extremely long operational range of over 20 kilometer detection. This is quite remarkable. Here you can see the picture and the interface control drawing of this lens. I would like to conclude my presentation with the following summary. Modern UAV and drones require reduced swap, high-quality optics. Long EFLs are required for long-range applications. Zoom lenses are ideal for UAVs, enabling high mission flexibility, small swap, and long ranges simultaneously. Folded designs offer many advantages, but are challenging. Ophir offers excellent optics design and manufacturing capabilities, as well as a large variety of existing zoom lenses for UAV and drones. Thank you.